Hi everyone, my name is Ravi Prakash and welcome to next session on linear tracks. So we'll start with this fantastic question here, okay, and we'll continue that concept of 2D from previous video, right? That concept of 2D, okay, linear tracks, 2D concept. So this question here, A and B started from two opposite points x and y respectively on a linear track towards each other. They first met at a distance of 70 meters from x. A continued walking towards y and B continued walking towards x. After reaching the end points, they turned back and again started walking towards each other. And second time they met at 20 meters from y. Find the length of track xy. Okay, so let's draw a track xy here. Linear track xy. This is x, this is y, okay, and two people A and B have started, right? A and B. So A started from x, B started from y, given it is respectively, okay. So A from x and B from y. This length of xy is not known, okay. So both started, okay. You should write one point here. You should add one point actually here, okay. So point you should add here, okay. That both have started simultaneously. Both have started towards each other simultaneously. Should add one point here, simultaneously, okay. That basically means that both started together, okay, fine. So both started together. So we'll see here. So both these two people are A and B, and both started together, and they first met at a distance of 70 meters from x. So let's say this is some distance 70 meters from x, okay. So this is the first meeting point M1, and this distance is how much? This distance is 70 meters. This distance is 70 meters, okay. So let's trace the path also, right? Let's trace this path also. This is B, this is A. Very important point right here. This question people use by solving, people solve by using lot of variables, right? Not required, no. Okay, because you can see there are very less information here, okay. So taking variables is the only option left, right? But we'll solve it beautifully by the concept of 2D, okay. We'll solve it beautifully by the concept of 2D. That is what we saw in the last video, right? So that 2D concept applied with ratio, it can be solved very nicely, this question, in a very fast manner, okay. So that's why it's a fantastic question, right? Because it has a very short solution and very interesting one also, right? Let's see here. So A has traveled 70 meters, B has traveled some distance, right? That we don't know, okay, fine. So A, suppose let's draw the path of A here. A has reached from here to here, and B has reached from here to here. Let's draw the path of B by blue one. This is the path of B, okay. Now B will continue, given that B will continue, B will reach x and again comes back, right? So let's say somewhere here, and let's say for A also reaches at this point y, okay, and again comes back, and let's say somewhere here, and let's say this is the second meeting point M2, okay. Let's say this is the second meeting point M2, correct, M2. So if this is a second meeting point M2, then it happens 20 meters from y. It happens 20 meters from y, okay. So it happens 20 meters from y, right? This distance is 20 meters, correct. This distance is 70 meters, correct. We have to find the length of track xy. You have to find the length of track xy. Now see, here the concept will come, right? Very interesting one. I know that till M2, combined distance traveled by them is 3D. Till M2, combined distance traveled by them is 3D. Combined distance traveled by them is 3D, right? That is D plus 2D 3D. Till combined distance, if I assume the length of track as D, right? If I assume the length of track as D, okay. So combined distance for them is till M1D, and then after that combined distance traveled is 2D, okay. So D plus 2D total 3D, okay. So I know that till M1 combined distance traveled is D, okay. So till M1 combined distance traveled is E. So in ratio, understand this very important point, in ratio, okay, when combined distance, when A plus B travels a distance of D, in that A travels a distance of 70, correct. When A plus B travels a distance of D, A travels a distance 70, right? When A plus B, A is starting from here, B is starting from here, right? Here. So when A plus B travels a combined distance of D, that is till first meeting point M1, A travels a distance of 70, right? That means till M2, if A plus B travels a distance of 3D, then A also travels, A should travel how much? 70 into 3, that is 210 meter. So A should travel 210 meter, right? So when A plus B travels a combined distance of D, when A plus B travels a combined distance of D, when A plus B travels a combined distance of D, A travels 70. So when A plus B travels 3D, A should travel 17 to 3, 210, right? Quite a simple ratio. When A plus B combined distance traveled is D, because their speeds are uniform, right? It is not changing. So in combined distance D, A's contribution is 70. So in combined distance 3D, A's contribution will be how much? 210, right? 210. So see, now we have solved this question beautifully, right? See, so total path of A, total length traveled by A till M2 is 210, right? So see this path here, right? This path here. By this path, how much A has traveled? By this path, how much A has traveled? So by this path, A has traveled this complete distance, right? A started from here, and this complete distance A has traveled, that is D. So by this path, A has traveled D and D plus 20 till M2. This is the path of A, right? This is the path of A till M. Here it is till M1, and then moves forward till M2. So A has traveled by this diagram D, total track length D plus 20. So D plus 20, and A actually has traveled how much? 210. So D plus 20 is equal to 210. Therefore D is equal to 90 meters. D is equal to 190 meters. This is the answer. This is the answer. A fantastic way of solving and a very conceptual question, right? So this question becomes very important because of the way of solving, right? This question may not be that teasing, because you can solve it by taking variables, right? You can solve by assuming D minus 70 and all, right? So you can assume it, right? But this question becomes the way of solving, right? This question is a fantastic one, right? Just have a quick revision. A and B started from two opposite points X and Y. Okay. A, when the combined distance traveled by them is D. Okay. So A has traveled 70. So till M2, combined distance traveled by them is 3D. So in every D distance traveled by both of them, A contributes 70. So in 3D distance traveled by both of them, that is 3 times D. Okay. A will contribute how much? 17 to 3, 210. Okay, so total distance traveled by A is 210. Total distance traveled by A. Total distance traveled by A is 210. Total distance traveled by A is 210, right? That means from here to here, he travels a distance of 210, right? From here to here, he travels a distance of 210, right? And the diagram again say what is the distance traveled? D plus 20. So D plus 20 equal to 210. So D is equal to 190 meter. That's the answer for this question. Correct? Okay. Let's move to next concept. Again, very important concept. Next one. Okay. So we are discussing here an important concept of linear tracks. Okay. Where two people start from opposite points and they run simultaneously. Okay. For example, let's see. Very important concept here. Okay. See this point. This is a linear track. Okay. Okay. Let's say this PQ is a linear track. Okay. And in this this linear track PQ, A starts at this point. Okay. So A starts from this point. Okay. And B starts from this point. Okay. And so points to be noted here are A and B started simultaneously. That means at the same time. Okay. After T minutes, they met at C. Okay. So let's say after T minutes they met at C. So now C is a point here, and A is taking both, since both have started simultaneously. So both will take T minutes to reach here, right? So after T minutes, The situation is, after t minutes, situation is A is here. Okay, A is here and B is also here, going to this side. So B going this side, A this side, right? Now suppose that B covers, this distance. So B has to reach point P. So B covers this distance in T2 hours. Okay, and A covers this distance in T1 hours. Right? Understand this point very carefully. Okay, so A covers this distance in T1 hours and B covers this distance in T2 hours. Right? This is what this A has reached here and this B has reached here. Okay, so after meeting at point C, A is taking T1 hours to reach Q and B is taking T2 hours to reach P. Fine. And let's say speed of B is S2, speed of B is S2 kilometer per hour, and speed of A is S1 kilometer per hour. Right? So what is the distance now? You can see here, this distance PA. Okay, this distance PA is covered by B in T2 hours at the speed S2. This distance PA, okay, distance PA is covered by B in T2 hours at the speed S2, which is the speed of B. What is the distance? Speed into time. Speed S2 into time T2. S2 T2. Similarly, so this distance is S2 T2. Okay. Similarly, this distance AQ, okay, is covered by A in T1 hours and the speed of A is S1 kilometer per hour. Okay, so speed of A is S1 kilometer per hour, speed of A is S1 kilometer per hour, and this distance AQ is covered by A in T1 hours. So what is distance? Speed into time, speed S1 into T1, S1 into T1, distance AP, distance AQ. Fine. So now this is an important point, right? This distance, since they have taken same time, okay, from A initially, right? Understand this point. A initially traveled from P to A, I've written after t minutes, right? So A initially after traveled from P to C. A has traveled from P to C. A has traveled from P to C in t minutes. Correct. And B has traveled from Q to A. B has traveled from Q to A again in t minutes, right? Both in t minutes, right? Correct? Because both started at the same time and initially, and after t minutes they met at C. And after meeting at C, B took T2 hours to reach P and A took T1 hours to reach Q, right? So after t minutes they have reached here, right? So what is the distance? What is the distance AQ here? This distance AQ is S1 T1. Distance AQ is S1 T1. Okay. So S2 T2 distance, right? This distance AP is covered by A in t minutes. So this distance PA is covered by A in t minutes, right? What is PA? S2 T2. Okay. This distance PA is covered by A in t minutes. What is the distance? S2 T2. Same way, this distance S1 T1 is covered by B in how much time? T minutes initially, right? I'm referring to initial case. So since time is same, okay, that means time is constant. So distance is proportional to speed. That means distance covered by D1 by D2 is equal to S1 by S2. Here A and B, therefore dA by dB is equal to SA by SB. dA by dB is equal to SA by SB. What is distance covered by A? So distance covered by A is what? A has covered a distance of S2 T2. A has covered a distance of S2 T2 in t minutes. So A has covered a distance of S. So dA is equal to what? dA is equal to S2 T2. What is dB? B has covered a distance of S1 T1 in t minutes. Okay, initially. So distance covered by B is S1 T1. Okay, this is dA upon dB is equal to SA upon SB. What is speed of A? Speed of A is S1. What is speed of B? Speed of B is S2. Okay, so very important point you get from here, right? you get from here that S1 square upon S2 square is equal to T2 by T1. Therefore, S1 by S2 is equal to root over T2 by T1. Very, very, very important point. Very, very important concept. When two people are starting at a point from two opposite points simultaneously, okay, so after meeting at a certain point, they reach their respective destinations in T2 hours and T1 hours, right? After meeting, time taken is T2 and T1 hours, right? Not total time. What is total time? Okay, let me just see this here. I'm taking this data in hours and minutes here. Change this on this to also hours, right? Change this in hours only. Okay, T hours you can make T hours. Didn't see that point. Okay, make it hours. Okay, because all are in kilometer per hour, so here also T hours I can take. T hours, right? So what is total time taken by B? Total time taken by B is T plus T2 plus T2 hours, right? T plus T2 hours, because B has taken from Q to C T hours and C to P T2 hours. So total time taken by B is T plus T2 hours. Similarly, total time taken by A is T plus T1 hours, right? A has taken initial time T hours to reach from P to C, and then from C to Q again T1 hours. So total T plus T1 hours, right? Very important point we got here. Okay, now second thing we can get here. See, this distance, this S2T2, right? S2T2 is a distance traveled by A. S2T2 is this PA. Okay, this PA is S2T2. Fine. So let me rub this part here. Okay, so I can write here. Okay, so in this part here, so this is the first one. I told I'll derive two things here. First, very important thing derived here. Now second thing, for second thing, you have to observe this distance here. Okay, this distance S2T2 is equal to this distance S2T2 is equal to, okay, this distance is S2T2. Well, if I compare in terms of T hours, right? So what was this T hours here? So A has taken T hours to come from P to C. A has taken T hours to come from P to C. To come from P to C, A has taken T hours at the speed S1. So what is this distance? This distance can also be written as S1T. This distance can also be written as S1T. Let me write equation 1. Right. Again, this S2T2 is PA. Okay. We calculated it in terms of B, that B has covered this distance in T2 hours at the speed of S2. So it is S2T2, this distance. The distance AP is S2T2. But if I calculate in terms of A, so in terms of A at the speed of S1 km per hour has covered this distance in T hours, right? From P to C. So what is this PC? Again S1T. So both are equated. Second time. So this distance AQ. This distance AQ is S1T1. Okay. So AQ is S1T1. So if AQ is S1T1, so again B has traveled it in T hours. Okay. B at the speed of S2 km per hour had traveled it in T hours. So what is this distance can also be written as? This distance can also be written as S2T. S2T, right? It's equation 2. Okay. So initially S1T1 and S2T2 are written in terms of B and A. This is written in terms of B and this is written in terms of A, right? So but in this in terms of A will be how much? S1T, and this in terms of B will be how much? S2T. So both are equal. So I can multiply this two, right? Multiply 1 and 2. Multiply 1 and 2. Multiply 1 and 2. What you will get here? You will get S2T2 into S1 T1 is equal to S1 into S2 into T square, right? S1, S2 will get cancelled from both these sides. What is left is T is equal to root under T1, T2. Another super important point I got here. T is equal to root T1, T2. This is the second derivation. This is the first, this is second. So two very important derivations in this video, right? Right. Again, just what is the scenario? Two opposite points are P and Q. This is left side P, right side Q. Okay. So P and Q. A started from P, B started from Q. After T hours, they meet at A. Okay. After that, B takes T2 hours to reach P, and A takes T1 hours to reach Q. Okay. So that distance is in terms of S1 and T1 and S2 and T2. Okay. And similarly, A takes T1 hours to come here from P to C at a speed of S1. So this distance is also S1T. And this distance is also S2T because B has traveled at the speed of S2 for T hours. So this distance is so the distance is also S2T. S2T. So multiplying both the equations, we'll get T square is equal to root under T1 T2. What is T1 T2? After they took T hours to meet at C, if they start simultaneously, right? This is very important point. If they start simultaneously, they will take T hours to reach at C, and after that T1 hours and T2 hours to reach their respective destination. Then relation between T1 and T2 is T is equal to root T1 T2. And same way first one is what? Their speed ratio is inverse of their square root of time ratio. Okay, so two very important derivation. Now we'll use this in following two questions. Okay, we'll use this in following two questions, right? Now see here. Following two questions we'll see. Now see this question. If Salman starts from A with a speed of 30 km per hour, right? So Salman and Shahrukh, two very good friends, right? So if Salman starts from A with a speed of 30 km per hour and Shahrukh starts from B at a speed of 8 km per hour, right? So let's say there are again 2 points A and B here. So we'll take 2 points A and B, right? So Salman starts from A. Salman starts from A at a speed of 30 km per hour. Okay. And Shahrukh starts from B. Shahrukh starts from B at a speed of 8 km per hour. The speed of Shahrukh is 8 km per hour. Okay, A. Towards each other from two opposite points A and B, they meet somewhere in between at C. They meet somewhere in between at C. Okay, suppose they meet somewhere in between at C. And they reach their destinations in 4 hours and 9 hours respectively. So they reach their destinations in 4 hours and 9 hours respectively. That means Salman took 4 hours, right? Salman took 4 hours to reach from here to here. Salman took 4 hours, and Shahrukh took 9 hours to reach from here to here. So 4 hours and 9 hours, right? So I have to find the distance between A and B. We have to find the distance between A and B. So we can do by both the funda, right? So again, suppose I'm using the first funda here. What is the first funda? Is speed of Salman by speed of Shahrukh, right? So we know that S1 by S2 is equal to root over T2 by T1. Correct. Just in the last slide we saw it. S1 by S2 is equal to T2 by T1, right? So that is a speed ratio. What is the speed ratio? So Salman's speed is 30. Shahrukh's speed is A. Is inverse of their time ratio. That means you have to take time of Shahrukh here now. What is time taken by Shahrukh here? 9. Okay. So time taken by Shahrukh here is 9 and time taken by Salman is 4. So this is speed of Salman. This is time of Salman. So inverse ratio, right? So how much it is? Therefore 30 by A is equal to 3 by 2. Therefore you'll get A is equal to 20. So speed of Shahrukh is 20 km per hour. Right? So what is distance between A and B? So what is distance between A and B? Easily calculated, right? If the speed of Shahrukh is 20 km per hour, so Salman at the speed of 30 took 4 hours to reach here. Okay, from here to here. So 30 into 4, this distance is 120 km. And Shahrukh at the speed of 20 took 9 hours to reach here. So 20 into 9, this distance is 180 km. Right? So 120 plus 180, total distance how much? Answer is 300 km. This is the total answer. Correct? Right. You could have also calculated T here, right? You could have also calculated T here using the second funda. What is second funda? T is equal to root T1 T2. What is T here? Time taken for first time to meet each other. So what is root T1 T2? Root 4 into 9. So root 4 into 9 because 4 into 9 is right. So T is equal to how much? T is equal to 6. So total time taken is 6 hours, right? So that means they both traveled for 6 hours, right? They both traveled for 6 hours. So you can calculate it easily, right? Here also you can easily calculate that Salman at the speed of 30 traveled for 6 hours to reach from here to here. So 30 into 6 is 180 km. Don't forget that T is the initial time taken. That means initial, both started at some point and are just after 10 minutes they first met, right? So T is the initial time taken for both of them to meet at some point C. So Salman traveled for 6 hours to reach 180 kilometer, and Shahrukh traveled for 4 hours at the speed of A, right? So I know that after their meeting, right? Now Salman has further taken 4 hours to reach from here to here. Shahrukh had taken 6 hours from here to here, A. At A, the speed is at A kilometer per hour, time is 6 hours, right? But since I need to calculate distance, I can easily calculate by Salman is traveling at a speed of 30 kilometer per hour and it took 4 hours further. So 30 into 4, what is the answer? 120 kilometer. 30 into 4 is 120. So again, 180 plus 120 is what? 300, right? So same thing again, okay? So both the funda you can use as per our convenience, right? Okay, next question. Two friends A and B leave city P and Q simultaneously and travel towards Q and P at a constant speed. They meet at a point in between their two cities and then proceed to their respective destinations in 54 minutes and 24 minutes respectively. How long did B take to cover the entire journey between city Q and city P? Okay, so see, again same question, right? You could have got the answer also by now. P and Q are two cities, okay? A and B leave city P and Q. So A and B leave city P and Q, okay, simultaneously. They meet at a point in between two cities and then proceed to their respective destinations in 54 and 24. So after meeting at some point R here, okay, suppose A came here and B came here, okay. So A took further 54 minutes to reach from here to here, okay, and B took further 24 minutes to reach from here to here, okay. So how long did B take to cover the entire journey between city Q and city P, right? So I know that now this is also easy to calculate because I know here that if A starts from here, right, and A reaches here and B starts from here, B reaches here, okay. So they both take, suppose since they both started simultaneously, suppose they both took T minutes. So B took T minutes from coming from Q to R and A took T minutes from coming from P to R. And this is T1, this is T2. Same thing, right? So I know that T is equal to root under T1, T2. Because what is T1, T2? After meeting at a certain point, respective time taken by both of them to reach their destination. So after meeting time is T1, right? Not total time. What is T is equal to root T1, T2? That is root 54 into 24. Okay. So you can calculate here. This is root 9. This is 9 into 6. You can say it is 4 into 6. This is 6 into 6. Okay. So this is 36. So T equal to 36 minutes, right? So T is equal to 36 minutes. So if T is equal to 36 minutes, total time taken by B to cover the entire journey between city Q and city P. So total time taken by B is how much? So B has taken T minutes to reach from Q to R and then T2 minutes. So total time taken by B is T plus T2. T is now 54. Sorry, T is now 36. T is now 36 and T2 is now 24. Okay, so 36 plus 24. What is the answer? Answer is 60 minutes. So time taken by B to cover the entire distance is how much? 60 minutes. Okay, I hope it is clear, right? Okay, so we'll continue this linear tracks in the next video. We'll continue this linear tracks in the next video. Okay, thank you.